And if it tells you the derivative is 0 or undefined, then what does that tell us about f of x?
I don't know. There's
Could be.
the relative max or min.
Yes, could be. So has
Ifs.
a potential relative max or min. An example of where it's not, I'm trying to find somewhere to zip this.
Would it be like kind of
Oh man, that's terrible. Yeah, it would be like,
oh, you erased the lines.
well, I'm going to put them back.
I didn't know you could erase the lines.
Like that. This is an example right here. It's supposed to be flattening out, but it's not a max or a min. So at this point at 0, 0, it would be 0, but it's not a max or min. So that's why I have to say it's a potential relative max or min.
We've never actually had one of those. Well, we've already had one, but it's not. Oh, the lines are back.
We will.
Did you just draw a white circle? I think she did.
drew
I thought you were erasing the line. I don't think she can.
No.
I didn't think she could either.
There. Is if f prime of x is greater than 0, what's true about f of x?
It's increasing.
It's increasing.
Yes.
Yeah.
Positive increasing.
It doesn't even have to be, f prime of x is positive, but that doesn't mean it is positive. For example, this right here would have a positive derivative. But notice g of x is negative. So it's not whether it's positive or negative, it's whether it's increasing or decreasing. So then f of x is increasing. Okay, what about when f prime of x is less than 0? It's decreasing, yes. It is. A lot of words for some math. So, if it changes from positive to negative, that's a relative max. And if it changes from negative to positive,
Relative min.
there you go. Okay, so the first derivative is what tells us if it's increasing, decreasing, whether we have a relative max or min. The second derivative, it tells us whether it's concave up or concave down or has a point of inflection.
Ooh.
Ooh.
It inflects upon it, so.
So, let me show you what it looks like. If it's concave up, it looks like that. Up. See the U? And concave down. Looks like the end that, and the end there is concave down. So here is g of x that we had earlier. We could, let's see, oh, it says that we found the points of inflection last year. I don't think we actually did.
I don't know.
I don't think we got to that.
How much stuff did we not get to?
Oh, like 2 months worth.
Yeah, pretty much. But it's okay. It
Second
doesn't
or
even
something.
matter. This, we'll just skip that. We're going to go finding it with calculus. It's better anyways.
Oh.
All right. So we're going to skip right to the next one. G double prime of x, and then do a sign analysis for this.
I have an odd question that relates to this question.
Yes.
Did your AP curriculum change? Like, did it drop some stuff or no?
No.
Some classes it dropped curriculum.
Well,
Like,
There's some things that they're not focusing on as much, just because. But
like they've dropped entirely units.
see, they can't really do that with like I said, because we need A to get to B, we need B to get to C.
But how can you do it with physics?
Yeah, physics dropped 2 entire units.
It was probably at the end.
He said it was electricity or something.
Electricity
Oh yeah,
and circuits and all that.
they usually don't get to that anyway. Honestly.
Well, we're almost done.
Wow. Okay, moving on.
Do you know anything?
So, G double prime of x. That just means we start off and we find G of x. G prime of x, sorry. And then we're going to take the derivative of that, and that would be the second derivative. Okay, so G of x was x cubed minus 3x squared. Make this a little bit bigger. G prime of x then is
3x minus
3x what?
6 squared. Oops. Minus 3x. Not 6x. I fixed it. I'm fine. Wait.
I love it. Okay, so there's G prime of x. What about G double prime?
6x minus 6.
Then it says, at what values of x does the sign of G double prime of x change to a sign analogous by conclusion, blah, blah, blah. Okay, so it works out the same as with the first derivative. Over here, and we've done this before, you took the first derivative and you found out where it was equal to 0.
1.
And you found out for f of x where it was undefined. Same thing here. Where is it equal to 0? Where is it undefined? Well, it's not undefined. But we can set it equal to 0.
1.
You're right.
Is it? Oh, yeah, it is, because that negative doesn't go away.
This is what's called a possible point of inflection. PPOI.
What does it mean by possible?
It means it might be a point of inflection.
Well, what might be there if it's not?
And if it's not, then it just, you have to check out your signs and see if it's changing. So what I mean by that is, just like with the relative max and min, how it could do that, it could be doing something and not changing concave in there. A point of inflection just means where does it change from going concave up to concave down, or concave down to concave up.
Inflection is the in between.
Inflection is the point at where it changes concave.
Cool. I've never inflection.
It's like really like they look like they're looking at each other.
Yeah.
I just couldn't know my head.
Well, yeah.
Cause like here's an up,
My
here's
phone.
a down.
Is that my phone?
Here's a down, here's an up. They're here.
Give me a second.
They're looking at each other.
You get new AirPods.
Oh, never mind.
Fake one?
Face one?
Yeah.
Wait, can I see?
Okay, here we go.
You know, look the same.
So,
Oh, they not the button.
There's no.
sign chart at 1.
That's what
This time we're doing G double prime of x. What do you want to plug in?
10.
0.
Equip it to 10.
So that's
his opinion's irrelevant.
0 and
So what we're doing is we're plugging that in to this.
so
Negative 6.
1.
It's negative, right?
Wait. Yes.
It doesn't matter if it's I lost it.
Yeah.
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 Oh, it doesn't matter what the actual answer is. It's just is it positive or negative. And then on the other side of 1, so I'm going to plug in 2. Okay.
Positive.
That one's positive.
So is this
So say that again.
So x equal 1 is relatively.
No, x equals
Concave
1
down?
is a point of inflection. This is a second derivative. Huh?
Does it change from concave down to?
Yeah, yes. This one means that, is that what you were going to say?
I said concave down.
Yep, this one is concave down. This side is concave up. And so at 1 is where it changes.
Maybe in the middle.
Yeah.
So, yeah, well, we can look at the picture.
Oh.
She just got so upset.
Here's the picture. Where did we say it was? At 1?
1.
One. Oh yeah.
It's when they look at each other.
So it's about right here. So on this side, notice it's concave down. On this side, notice it's concave up. And right where it changes inflection, or concavity, is the point of inflection.
Concavity.
That's a weird word.
You got a concavity.
I want my dentist to tell me that.
Okay, so now we're going to talk about how the second derivative relates to the original function. So if the second derivative is negative or is undefined, then what does that tell us?
Inflection. I don't know.
Possible.
Yes, it has a possible or potential. It's another word you might hear. Point of inflection. What if the second derivative is greater than 0?
Concave up.
There you go.
I thought that was like the bottom ones.
The bottom.
What's the bottom ones? If those are concave up and concave down, what's the bottom?
I've done it. Points of inflection.
Yeah, but like I thought we were different.
We've described a potential where it might be.
It'd be the
bottom ones are where they are.
The bottom ones. What are you talking
Oh,
about?
the
Changes
change of possible, like positive to negative, and change.
Oh, yes. Okay. Yeah. Hang on. Let's finish this. So for the next one,
Concave down.
yeah, this one is concave down. So this one's saying if it's going from concave up to concave down,
Mm-hmm.
then this is, what is it?
A point of
Point of
Yes.
inflection.
And that's both of them. So where it changes is the point of inflection.